Good evening and welcome to another algebra lesson. Today we are beginning chapter 5, and chapter 5 is all about linear equations. And something that is a contributing factor in linear equations is something called rate of change and slope. So today what I'd like for you to be able to do by the end of class is to be able to find rates of change and slopes from tables, graphs, and points. So let's jump right in and figure out what rate of change is. Rate of change shows the relationship between two changing quantities. And then when one quantity depends on the other, the following is true. Rate of change is going to equal the change of the dependent variable, or the y's, over the change in the independent, or the x's. So it's change in y over change of x. I'm going to highlight that because rate of change is pretty important. All right. So let's look at our first example and see how rate of change is involved in that. It says the table shows the distance a band marches over time. What are the dependent and independent variables? Is the rate of change with respect to distance and time constant? And what does the rate of change represent? Okay, so I'm just going to say A, B, and C just so you can see where I'm putting stuff. So for A, it says what is the dependent and what is the independent variables. So remember, independent doesn't need anything. It gets to equal whatever it wants. Dependent is influenced by the independent. So here I have time and distance. Time is influencing how far the marching band marches. So distance is dependent, time is independent. All right. Then it says, is the rate of change constant? So here we can just look at our table and consider how it's changing from one to the next. So this one's plus 1, plus 1, plus 1. And then how these are changing from one to the next as well. These are increasing from 260 to 520, you add 260. From 520 to 780, you add 260 again. And then to get from 780 to 1040, you add 260 again. So notice how all of these plus 1, plus 1, plus 1, plus 260, plus 260, plus 260, which means this is remaining constant. So yes, it is constant. And then for part C, it says, what does the rate of change represent? So remember what this table is telling us. It's saying as 1 minute passes, the distance traveled is 260 feet. As 2 minutes pass, the distance traveled is 520 feet. So the rate of change represents how many feet are marched per minute. All right, so now we're continuing in the same example, and we're going to take it a step further. It says plot the given points on the graph. Okay, so our coordinates are right here. Remember, this represents x and y, so I can put that up here just so you can see it. So I have a 1 and 260, 2 and 520, 3 and 780, and so on and so forth. So I need to label my graph in a way to where I can fit this stuff on there. On the bottom is going to be time, so I'm just going to write that right here. And I'm going to say every 2 is 1 minute. So 1, 2, 3, 4. Next, I have really big numbers. It starts at 260. So I'm going to do something called a break in the graph. And it's basically where you just do that. And you get to start at a higher number up in order to not waste space. So I am going to start at 250 right here. And then I'm going to count up by 50s. So 300, 350, 400. Okay. I know I won't be able to get this last one on there, but I can at least get 3 of the points, and that'll be enough to get a line. So my first coordinate is 1, 260. So I'm going to go over 1 and then up to 260, which is going to be about here. Then I have 2, 520. So I'm going to go over 2 up to 520, which is about here. And then I have 3, 780, so I'm going to go over to 3 and up to 780, which is going to be approximately there. Okay, so now I have my 3 points. Sorry, I did not have that in there in the shot for you. So I went over 1, up 260, over 2, up 520, over 3, up 780. And now I'm going to connect them as best I can. And there is my plotted line. Now let's talk a little bit about what this graph looks like. It says the graphs, or the graphed points, form A, and we connected them, and so notice they form a line, which means this problem is, you've heard this word before, linear. When a graph is linear, it has a constant rate of change. So we actually talked about that up here in problem B when we identified the rate of change as being constant. And so we can notice this line does not have any curves or bends or jagged angles. So that means it is consistently increasing and it doesn't have fluctuation in that rate of change. Now a little bit more vocabulary. The rate of change is the ratio between the vertical change or the rise compared to the horizontal change or the run between 2 points on the line. Okay, so we've already said rate of change is the change in dependent over change in independent, or change in y over change of x. This is all saying the same thing, just using different words. So dependent over independent, y over x, vertical over horizontal, up and down over left and right. All of those are meaning the same thing. So we do have a formula for this, and it's all going to, like I said, represent the same thing. So slope is oftentimes represented with the letter M. M usually means slope. And slope, the formula for slope is going to be something called y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We're going to be looking at that formula a lot more closely tomorrow, but I'm just introducing it to you now. So I'm going to kind of box this or bubble it in because that is important. And then right here, this and this, same thing. Slope is equal to M, which is equal to vertical change over horizontal change, or rise over run. I'm asking myself, how high up does it go, or down low does it go, and then how far left and right? So when we're looking for the slope of something on a graph, and let me highlight this a little better for you guys because I don't feel like it's as clear as it could be. That's the line we're looking at. The axes are right here. And the points on that line are right here and right here. Okay. So when we are looking for the slope, we are asking ourselves how high up and how far over is it from one point to the next. So I'm going to start right here. And how am I getting from this point to this point. How far up do I go? I go 1, 2. So I go up 2. So I'm going to say rise over run. So it rises 2. And how far does it run? 1, 2, 3. So 2 over 3 is my solution there. For this next one, let me kind of get it highlighted for you as well, just so you can see it a little easier. Okay, how am I getting from this point to this point? What is my rise and what is my run? Rise, this time I'm going down. I'm going 1, 2, 3, 4 down. So down is going to be -4 over, and then how far to the right? 1, 2, 3, 4, 5. So I'm going down 4 over 5, which means my slope is -4 over 5. Let's do that again with a couple more pictures just so we can see it. So here are my coordinates. Here's one right here, and here's one right here. And I'm asking myself, how high up and how far over do I have to go? So how high up do I have to go? And then how far over do I have to go? All right, so let's count. I do rise over run. To rise, I'm going up 1, 2. For run, I go 1, 2, 3, 4, 5. So I'm going up 2 over 5, and that's my slope. Over here, I'm finding my 2 coordinates again, and we're purposely using points that are easily like at an exact point. We don't want to use points like, say, this one or this one, because it's kind of in the middle and we would have to estimate, and we don't want to estimate. We want to be as exact as possible. So for this one, we're going to ask ourselves how far up and down and how far over. So how far up and down, how far over. So we got rise over run. Rise, we're going down 2, so that's -2. And then run, I go 1, 2, 3, 4, 5, 6 over 6. So this is -2 over 6. But something with slope that you should be mindful of, if you can reduce it, then you should reduce it. So this is going to actually be -1/3 for my final answer. So remember, slope is the vertical change over the horizontal change, or rise over run. We're going to be looking at that equation more tomorrow. Finally, we just have something called summary of slope, and I'm doing this just so you can see the 4 types of slope. We have a positive slope, a negative slope, a slope of 0, and an undefined slope. So a positive slope goes uphill from left to right. A negative slope goes downhill. This right here is a 0 slope. You're not going uphill or downhill, you're just staying flat. So this is going to be a 0 slope, which is horizontal. And this one is going to be undefined, which is vertical. And there you have it. We are going to be spending a second day on slope, so we will practice more. And if you have questions about slope or rate of change, be sure to bring them tomorrow to me in class. Have a good night.